Good afternoon, everyone. Welcome to KINO, a next-generation hardware-agnostic factory uptime system designed specifically for Honda Canada Manufacturing in Alliston, Ontario. Now, you guys probably know about this plant because they produce Honda Civics and CR-Vs, but they produce a third, lesser-known commodity, data. They churn out billions of data points every single day, from telemetry to past problem history, human interaction, and even production line data. This essentially turns the factory into a live data lake. We can leverage this data to better predict and prevent failure at the factory, and we can even recover when there is a failure point. But before we get into what KINO is all about, let's take a look at just how damaging downtime can be. The Honda Civic and CR-Vs have an MSRP of $36,000 to $40,000. Assuming a vehicle is produced every 60 seconds with 35 to 40 minutes of downtime per working day, this amounts to $760 million of loss annually, or $1,267 a second. So what is KINO? There are 4 primary pillars to this solution. The first one is connection. Everything in the factory, from individual machines, hundreds and thousands of sensors, and even the human interactions in their daily workflows are connected under one unified, omnipresent system. This leads into the second pillar, KINO AI. This system allows frictionless, autonomous workflows and data pipelines, so crews, such as maintenance and engineers, can get relevant, real-time data immediately. This is powered by the third pillar, data. We churn out billions of data points, which we then harvest and train our proprietary machine learning prediction model to be able to tell you exactly what's going to happen before it does. All of this is wrapped under our digital twin, a digital recreation of the Honda manufacturing plant with everything available at your fingertips. So how do we predict, prevent, and recover from failure? We predict using machine learning and our billions of data points. We prevent using a past performance history to pinpoint failure with accurate root cause analysis, and we recover using real-time data and diagrams of every machine to provide the maintenance crews with accurate information. An example of how we do this is actually the arms that we tested Arduino on a few hours ago. So for example, the arms were made by Universal Robots. We are able to feed this into our AI model with relevant documentation, which can include valuable baseline data points, such as what the operating temperature should be. This allows our sensors and our AI model to accurately determine if something is wrong. This, all in all, allows us to maximize mean time between failure and minimize mean time to repair. Now, without further ado, let's show you KINO. So we can go to our homepage and we can speak with KINO AI. Now we can either speak to it directly or ask, how is my factory doing?
Honda Meridian Factory 12 machines. Average risk score, 33%.
So as you can see, in real time, it can give you data points on what's going on and what is happening exactly. We simplify data points by putting it into 4 categories: critical, elevated, caution, and healthy. But you can dive deeper into this within the dashboard.
Okay, so the KINO dashboard, let's say when you set up a new machine, it's going to set up a new link to your dashboard. Right here, let's give it a name. And then basically we give it what you want it to do. This is to prevent the 4 N's. So we give it some files, and this way it will have all the context when the engineer comes. Save configuration. Now let's look at the digital twin. This is a 3D view of your factory. You can see where everything is when you need to send your engineers. Now, this is very important because we know the Honda engineers can't always be looking at dashboards. That's their biggest issue. They can't come back to a computer. They need all the time references. So let's look at the machine. It'll tell you your health score, but the most important thing is if health score is too low, it'll automatically send the SMS. Or let's say you want to send an automatic SMS, send an engineer, and I got that, and then
putting in his password.
As you can see right here, we got a new SMS message right here. That's coming directly from our system. You can also set rules. So let's say you want a rule to happen for your machine. Let's say I want vibrations to come if they're above 70%. That's most likely the bolt for, I don't know, the paint machine. Add rule. And just like that, it'll send me the SMS if the rule gets triggered. Now let's go on to the
So circling back to the centralization aspect of the solution, everything from maintenance schedules to machine locations is all centralized. This allows the AI to gain context into what's happening. For example, sometimes machines break down not because of the machine itself, but because something in the conveyor belt, for example, before it went wrong. And this can visualize that for the human and also keep contextually for the AI to take autonomous action upon. We also have a failure chain. So this builds upon what I just said, where it breaks down exactly what the failure was and how it translated to other parts of the factory. And this is where our predictive machine learning comes in. So based on current and historic data, it is able to plot out the likelihood of failure as time goes on per machine. And we even have a fleet intelligence system, which is able to tell you exactly what is happening, when, and it enables Honda to eliminate downtime entirely. This has been KINO, and thank you for listening.
We're a little out of order, guys.
We're ready.
Thank you for your presentation. Very good presentation, very easy to follow what you guys are targeting. Just, I guess, a application question. So, technology is great, but then you're sending out good information to relate to, hey, there's some problem, but how do we break down the problem in the sense of equipment? And the equipment can be what you're building. So how does maintenance or engineer come to the site to modularly break down the problem and understand where they should be investigating and be able to rule out so that we can have maybe parallel kind of activity?
So before the error even occurs, we upload manufacturer documentation, such as diagrams and other technical information, into the AI system. And this, in tune, works with the sensors implemented in the system, so that if something goes wrong, it analyzes that data to check if it's off baseline, references it back to the diagrams, and immediately notifies the maintenance and engineering crews so that they can come and repair it as quickly as possible. And they do this, the AI does this by only providing relevant documentation as to minimize mean time to repair.
If you also saw, I don't know if you saw in the SMS message I got sent the actual diagnostics of the machine. So let's say vibration was too high, the engineer might know what that meant. So they might know, oh, vibration is too high, there's probably a bolt missing, right? So that's where our sensor data comes into play here. And that's how, when the health is low, it doesn't mean just health is low, it means something actually went wrong, and that's what we're sending to teams. We also made sure that there's a feature where you can send multiple teams. For example, the repair team and the engineer team, because they might know different things, and them together might lower the mean time to repair.
We can also integrate all the failures and all the diagnostics into the Maximo software that we are already using, so the maintenance person knows all the context, historical failures, and all the diagnostics and telemetry data, so that it is easier for him to go and reference all the historical data and diagnose the issue better.
Not a question. Oh, sorry.
Not a question, just a comment. So I'm impressed so far that both teams have picked up some of the Honda lingo. So in your case, you know, you referenced MTBF and MTTR. I mean, it's not Honda lingo, it's industry lingo, but you know, you talked about the different sources of data at Honda. You talked about the 4M method. You know, in your Q&A here, you referenced Maximo. So I'm glad to see you guys are paying attention. I think the first team talked about FTAs and 5 Whys. So you have absorbed a lot of information, created a proposal, and you were obviously listening at the same time. So that's great. Thank you very much.
You had a great factory tour, so it helped.
That's great. I'm glad.
So we actually got that data last night. That was what you were seeing on the screen because this wasn't plugged in. We got that data last night when we were testing it, and that's what we were using right here because we knew there was going to be no robot here. We couldn't set up in time, so we kind of copied all that data, put it into some static files, and that's what was running back there.
Thank you so much. One last question. It's the cybersecurity angle, so AI, cloud-based, all that. So talk to us about some of the risks in the solution that you in KINO or AI from a cybersecurity perspective.
Well, every time you put all data into a single node, for example, KINO, you get the benefit of one analytic pod. But the danger would be you have a single point of failure. However, this can be done by isolating KINO on its own, so we call it air bubble, where it's no other, like it's only connected within the factory information. And on the other aspect is using so the AI at KINO it finds the relevant documents. So it's not fully generative because in a factory place it has to be very reliable. So in that way, someone cannot try to connect over the AI through a network and make the AI do something malicious.
Great, thank you.
All right, well done, KINO. So we're going to give again the judges a moment to be able to sort of absorb that too. Thank you so far to all the groups for making the judges' job very difficult because you certainly are. So I appreciate that.